to subscribe. The distances of the relatively close stars are calculating by the parallax method. Thanks to the Gaia satellite that was launched by the ESA in 2013, more precise parallax measurements determine the distance of the stars in the range of 10,000 parsecs, i.e. 32,600 light-years. The distances of the more distant stars can be calculated using the variable stars. The astronomer Henrietta Leavitt discovered the relationship between the magnitude and period of Cepheid variables. At the Harvard College Observatory, studying photographic plates of the Large and Small Magellanic Clouds, compiled a list of 1,777 periodic variables. Eventually she classified 47 of these in the two clouds as Cepheid variables and noticed that those with longer periods were brighter than the shorter period ones. The Danish astronomer, Eginar Hertzsprung, quickly realized the significance of this discovery. By measuring the period of a Cepheid from its light curve, the distance to that Cepheid could be determined. He used his data on nearby Cepheids to calculate the distance to the Cepheids in the Small Magellanic Cloud as 37,000 light-years away. Harlow Shapley recalibrated the absolute magnitude scale for Cepheids and revised the value of the distance to the Small Magellanic Cloud to 95,000 light-years. In 1924 Edwin Hubble detected Cepheids in the Andromeda Nebula, M31, and the Triangulum Nebula, M33. Using these he determined that their distances were 900,000 and 850,000 light-years respectively. Let's try to calculate the distances using the Cepheid stars to some members of our local galaxy, the Small and Large Magellanic Clouds, Andromeda, Triangulum, Pegasus, and NGC 3109 galaxies. In order to be able to calculate the magnitude-period relationship, we must first determine the absolute magnitudes of the stars. The absolute magnitude of a star, m, is the magnitude the star would have if it was placed at a distance of 10 parsecs from Earth. The magnitude system invented by Hipparchus. He arranged the visible stars in order of apparent brightness on a scale that ran from 1 to 6, with stars ranked 1 being the brightest. Today, the brightest visible star, the Sun's apparent magnitude is -26, the fainter the star's apparent magnitude, Hubble Space Telescope can see, is 29. Magnitude scale is backward and logarithmic. Each magnitude change is 2.512 times different. So, there is 100 times difference between 1 magnitude and 6 magnitude. It decreases logarithmically. Distance and magnitude are inversely proportional. The distance-magnitude relation is as follows. If 2 of the 3 unknowns are known, the other one can be found. So, if distances of stars calculate by parallax method, and determine the apparent magnitudes, absolute magnitudes can be found. Let's see the relationship between period and absolute magnitude by calculating the distance of 34 classical Cepheid stars in our galaxy by the help of parallax angles measured by Gaia satellite. The long-term observations of Cepheids, whose visible magnitudes change periodically, need to be weighted mean of their apparent magnitudes, but I don't have these datas, so I used the absolute magnitudes by using arithmetical means. With the help of the Grapher 13 program, if period and absolute magnitude values draw on the graph, a linear function can be obtained by the root mean squares method. As the function we have obtained shows the relationship between the period and the absolute magnitude, we can now calculate the distances by using the period of Cepheid stars detected in some galaxies in the local group. By calculating the distance of more than one Cepheids detected in a galaxy, by taking arithmetical means, the roughly distance of the galaxy in which Cepheids belong is calculated. Variable stars and distance calculation effective up to 13 million light-years away, as the Earth-base observations due to the atmospheric effect. Thanks to the Hubble Space Telescope, as the faint and distant stars can be observed more precisely, the much more distances can be calculated using variable stars. A galaxy in the Virgo cluster called M100, astronomers used the Cepheid variables observed there to determine its distance nearly 56 million light-years.